operator, and it is said to be a costlier operator also. And then we have seen that there are various forms of join. So we have seen that there is natural join, or I mean, you may please help me in finding out or listing down the various forms of join operators. Rocky, can you just
Yes, sir. Yes.
help various forms of the join operator?
So natural join, semi join, left
Okay.
outer join, right outer join,
Natural join, semi join, and then
left join, right join,
left join, right join. Okay. Outer join there. Okay.
outer join.
All right. Then, uh, yeah. Vishal, can you tell any other types of joins other than what Rocky has already told?
So left outer join.
Yeah, that he
In
has
a,
told.
so
What is theta join, Vishal?
first we need to make projection, and then we need to.
We are not audible. Louder, please.
So first we need to do the projection, and then we need to.
Theta join. What exactly theta join is?
Sorry, sir, I can't recall it.
Ajwad?
So, in theta join, we will be having condition. We notate it as theta.
Okay.
We will be having
Taking
some kind.
joins of two tables or few tables based on condition. Theta is actually referred as a condition. Conditional join. Anakha, what is EQ join?
Hello, sir.
Yeah. EQ
Sir,
join.
when the condition is equal to, it becomes equijoin.
Good. Okay. Arka Jodi, what is this semi join?
Hello.
Yeah. Tell me.
Semi join is I think where like one condition should be matched in two tables.
No, not no. Other, other.
Yes, sir. In a semi join, we first check the condition and figure out the result from one table before sending it to the next table for join. So,
Okay. In semi join, we are actually, I mean, one join is done in actually two steps. So first you, I mean, when you call it as semi join, the other join is actually called full join. So taking join of R and S, R full join S is regarded as R semi join S, full join S. Similarly, S semi join R, S join R, S full join R, it can be done in two steps. S semi join R, then full join R. So, instead of taking a join with the whole table, you take a join with a component or a part of the table, and then you take the full join. I think you remember the diagram that we have shown in the last class, where first you do a projection, then project out those columns and send to the other table, take the join, then the result is sent to the first side like that. All right, so semi-join. Where exactly these semi-join operators are widely used, Avinash?
Yeah, yes, sir.
Please answer.
I think, sir, most of the time it is used wherever we have to duplicate, means we have to find out the subqueries without actually duplicating them.
No. Let me, Tarun?
I think, sir, where the two databases are located in different sites, like different places.
What is it called?
Distributed database system.
Distributed data. Yeah, when the database is having physically distributed data, we use the semi-join operator while. So what is the real advantage of going for semi-join, Devendra?
Sir, actually, we are finding a part of a, we can say, subquery and search in the other table or the other part of the table. So in the distributed, as the table is not present in the same place, so what we will do is that first we check the condition and find out the subpart of a table from one place and check on the other place. Sir.
Oh. So what actually we are optimizing?
So we are optimizing the time, sir, for searching.
Optimizing the
Time, sir, time. Because we are not actually performing the join operation, which take a lot of time from the distributed computing as the.
okay.
So,
Yeah, Divyanshu, can you add something more to that?
Sir, I think we are saving one transfer of database.
Yeah,
Because
Devendra
first
is saying that time for query processing is going to be optimized, or it is going to be minimum if we use
Yes, sir.
semi-join. Do you agree, or can you refine that further?
Sir, I agree with Devendra, and I want to add one thing. I think we can also reduce the cost of transferring, na, sir?
Yeah. So communication cost is reduced, or what Devendra has told is also correct, because if you are getting data, huge tables from other sites or nodes of the network, definitely the time for transfer will be more, cost will be more. Both will be high, both can be optimized or can be minimized if we go for semi-join, where you are sending only a portion of a table. All right. So Vikram, Deepak.
Yes, sir.
Yeah, this join is done in two steps now. As I told, R join yes is actually done as R semi join as full join as. Won't it be taking more time rather than straight away taking join of R and S?
No, because first in first join we are reducing the number of tuples, right? So time is reduced.
All right. Okay, actually it depends upon the size of the tables R and S and also from where the query has come. So we compare the size of the tables and I mean size means the number of tuples in the two different relations or tables and then decide whether to apply semi-join or not. That means don't be under the impression that always semi-join will reduce the cost. Sometimes if it is not applied properly or on a specific context, it may not be giving you the required results. All right. All right. So we will come back and see about joins. The discussions are not yet over. So we'll have some examples later on: left outer join, right outer join, and full outer join, etc. in one of the coming classes. In any case, join is a very, very important or a very significant operator. And for your information, in modern databases or the so-called big data databases, what is the role of join operator? Divyanshu. You have already answered, isn't it? So let us move to Vikram. Vikram Deepak.
Yes, sir.
Yeah, in modern big data databases, how popular joins are?
Very popular, sir.
Minimum. Minimum or maximum?
Sir, joins are very popular.
Very pop. All right. Kekelo, Laushe.
Yes, sir.
Kekelo. Yeah, Kekelo.
Yes, sir.
Yeah. How popular or how much it is recommended to use join in modern big data applications?
Yeah. With joins, we can find the relation between the two tables.
It is recommended widely.
Yes, sir.
Okay, Lakshmi Shetty Satya.
Yes, sir.
Yeah. What is your answer?
I also think it is widely popular, sir.
Widely used. Megha.
Sir, it's very popular because it helps to combine the data from two or more DBMS tables.
Okay. So in fact, in big data applications, people try to minimize the use of join. Yes, already we know that taking cross Cartesian product of the tables and then doing selection, projection, etc. are going to take huge amount of memory. This big data itself is in terms of people talk about gigabyte size or mega terabyte size, even for one column. So there, if you go for the join operator, it will be disastrous. In the sense, it will be taking too much time, too much memory, etc. So big data itself is talking about huge volume of data. So the application of join is minimized in the context of big data application, or in big data context, the whole concept of relational model itself is not promoted because of the dependency on the join operator. So in the relational model, this join is a very vital operator where all these operations are basically around the join operator. So join is actually the weak point, or it is actually the weakness, or the whole relational model suffers from the dependency on the join operator. Whenever there is a query spanning into more than one table, the default choice is a join. And if you are trying to take a join of big data tables where, or I mean, databases where you have big data, huge volume of data, you will be eating up the main memory, or you will be taking too much time. So it is totally avoided if possible in the big data context. So what you will do? What is the substitute for big data? Use.
I don't know exactly about it, sir, because as the data size will be very large, to maintain it,
So,
it will take time.
so that is why we are saying that join should not be used much. What is the alternative?
I don't know.
Eshwani?
Sir, I don't know what is the alternative to that.
All right. So what is happening is, for your information, the relational model itself is not recommended in the modern distributed, I mean modern big data applications. So they have some other model other than relational model, and it is known as what? Rahul Moharana?
Yes, sir.
Yeah. So what is the model which is normally used in modern big data applications?
SQL.
SQL?
SQL query.
Rahul Soni?
So relational databases are SQL based and non-relational databases can be object-oriented databases or other databases.
Yeah. Anyone, please?
NoSQL, like MongoDB.
Okay. Who said that? Rocky.
Yes, sir.
Yeah. So that is the answer. Actually, in modern big data applications, you talk about unstructured data. So this relational model is actually talking about structured data, structuring the data in a particular skeleton form or in a template. When I talk about a student, immediately you say roll number, name, date of birth, class, semester, course, CGPA, all those things, mobile number, email ID. So we have a structure for the data. So when it is coming to big data applications, you may not be able to insist on a specific structure for all pieces of data. Some data may have some columns, other tuples or other elements may have less number of columns or more columns. So it is basically unstructured. So in an unstructured environment, the SQL standard may not work. So there actually you go for no SQL, not only SQL. So modern big data applications are, yes.
Sir, how does that improve the situation? Because in NoSQL as well, we use some sort of schema for the database.
NoSQL itself?
In NoSQL database also, we use some sort of schema. Means we define some kind of form for that document. So
Yeah, you provide
how is it
schema,
different?
and but they are not purely the relations. So in relational model, it is actually built upon the set theory. Or a relation is nothing other than the set theoretic relation. But there, when it is coming to NoSQL, it is not purely a set or not, it is purely based on a relation. So you go beyond that and you provide unstructured data. So MongoDB is an example where you have some portion which is structured and there can be other unstructured portions also. So the point that I want to make here is that join has become a biggest weak point, or it is actually the most vulnerable, or it is the point where most of the criticism on relational model has come. All right. So it is a controversial operator, we can say, because it is relational model is highly and heavily dependent on join. All right. Okay, so that was a quick overview regarding the relational algebra and the join operator. Anyway, please note that join is an operator which cannot be written off. It is highly and heavily used even now in the relational context. And whenever there is a query which is spanning into more than one table, you cannot do anything without taking a join of those tables. All right. Now let us move on to distributed databases. I'm sure you have idea regarding distributed databases. That is a database which is spread over a network. So these are the things, and we will see these things one by one. So this is actually a theoretical overview of a distributed database. So we have to study and we have to make a comparison between centralized databases and distributed databases. At the outset, let us try to find out some major differences with a centralized database. Sarita, at the outset, can you say how distributed databases are contradicting in a way to the centralized databases?
In distributed databases, the processing is happening in different places, and finally we are.
Louder, please, Sarita.
Hello, sir.
Yeah.
In distributed databases, the computations are happening at different places, and finally summarizing.
Okay. So where exactly some difference coming, conceptual difference coming. Santosh Kumar.
Sir?
Santosh.
Yes, sir.
Yeah. Conceptually, where distributed databases differs from centralized databases.
In distributed database, the data is uncertain. So
Louder, please.
In distributed databases, the changes
Yeah,
are
please
the
keep your mic close to your mouth. Oh.
Hello, sir. Am I audible now?
Voice is very feeble.
I don't know, sir. Like now?
Yeah.
Sir, in distributed databases, the data is very uncertain. Like the changes can happen from anywhere, like as it is distributed. In centralized, we maintain it is synchronized. Like we can maintain the changes for every time.
Okay, Sahil.
Yes, sir.
Yeah. So, can you add something more to what Santosh has told?
Sir, in centralized database, the whole database is stored in one location, but in distributed database, the database can be stored in different locations. And if centralized database, like there is some error in that, then the whole database will face some error, face difficulty. And in distributed, we can have a backup or a replicate databases. So in case of any failure, we can use other databases.
Yeah, that is actually the point. So, what Sahil told is about replication. So, in distributed databases, you promote duplication of data or you promote replication of data. Whereas in centralized databases, in normalization theory, what we have seen is minimize or eliminate redundancy if possible. So you are theoretically, you are trying to have only one copy for one piece of data. So we should not have multiple copies. That is a fundamental motto in centralized databases. When it is coming to distributed, you allow multiple copies. And if you have a very important data, you may allow copies at all nodes of the network. First, we were talking about the railway reservation example, etc. Suppose you have a train which is very popular all over the country, and there can be reservation requests for the train from every possible station. Then you may have a copy of that reservation data for that particular train stored at all the stations. So if you have a more demanding data, you have more copies of the data. So redundancy fundamentally is promoted in distributed databases, whereas it is minimized in centralized databases. That is actually the fundamental difference between these two. Any other difference fundamentally between centralized and distributed databases? Saurav Kumar? Saurav Kumar. Saurav Bandyopadhyaya?
Sir.
Yeah.
In distributed database system, as the data is located in different locations, so there is no chance of single point failure, but in centralized system, there may be chance of single point failure, I think. Like if the central server crashes, then whole data will be lost.
Oh, So that is actually an advantage of going for distributed mechanism.
Yes, sir.
What I am asking is the fundamental differences, fundamentally how these two are different, conceptually. One thing we have seen, centralized databases talk about minimum redundancy, but distributed talks about more redundancy. Redundancy is not a crime. Data replication is not a crime when it is coming to distributed databases. Whereas other centralized databases, you say that if there are multiple copies, then it is going to create a lot of problem, minimize, eliminate, etc. Like that, any other point?
Sir, the distributed databases are meant to be eventually consistent, not consistent all the time.
Rahul, data consistency. Rahul, is it Rahul who is talking?
No, sir, Athar.
Arthav, okay.
Athar, yeah.
Other, okay. Yeah. So what is the point?
Sir, I was saying that in centralized databases, the data is supposed to be consistent at all times. But in distributed databases, it is supposed to be eventually consistent.
All right. Very good point. That is, all data should be, all copies of the data should be always the same. So that is actually another motto that we follow or implement in centralized databases, which is actually called the consistency, strong consistency. So if you have 5 copies of the data, all 5 copies should always be the same. But that is relaxed in the case of distributed databases. In the case of distributed databases, as Adhar was told, you relax that and say that all copies need to be the same only in some periodic intervals. So every 8 hours or once in every 6 hours, you will update all the copies of the data in that. But it is giving importance for another aspect. So consistency is relaxed, and another quality of service parameter is given emphasis in distributed environment. What is that parameter? Ria, V. Ramesh.
Hello, sir.
Yeah. What is given importance or what is the focus of distributed databases? We have seen that consistency is relaxed.
Yes, sir.
Not very important.
Yes. I don't know, sir.
Okay, Saurav Kumar. In Saurav, you have answered any question earlier today? Saurav? No response. Suman Das. Suman Das.
Hello, sir.
Yeah.
In case of distributed database system, we can access the data easily. If in any point the data is any point failure is occurred, then we can access from different section. But in case of centralized system, that will not be possible.
Not clear. Anya Poranga.
Yes, sir. Sir,
Yeah.
I think data recovery will be easy in case of distributed database systems.
Okay. So here, yeah, that is actually the parameter which is called availability. All right. Consistency is relaxed. No need for strong consistency. At the same time, you increase the data availability. As some of you were saying, because you have more copies or more than one copy of a piece of data, so even if one copy fails, you will be able to work from the other copies. So you have better availability in the case of distributed databases. So distributed databases are giving emphasis on availability at the cost of consistency. So the focus, I mean, I was talking about optimization parameters, and all these are optimization problems. So here, the optimization parameter is actually the availability of the data. So more availability is actually the target or focus of distributed databases. All right. So I think the concepts are clear now. So distributed databases are promoting data replication, and they are also promoting data availability, and the traditional quality of service parameters like consistency and these design anomalies are not given very big, strong significance in distributed context. All right. So we will see these things in detail. So the advantages and disadvantages of distributed databases, functions and architecture of DDBMS, distributed database management system, then the design for distributed databases and the transparencies which are provided in DDBMS, comparison criteria for DDBMS. How do we compare different database, distributed database management systems? So DDBMS means distributed database management systems. Now we have some quick revision. What is a network? Interconnected collection of autonomous computers capable of exchanging information. We know what is LAN, what is WAN, wide area network. When the computers or LANs need to be connected over a long distance, we call it as a WAN, wide area network. And wide area networks are already slow and they are not reliable as local area networks. DDBMS using LAN provides much faster response time than using wide area network. So wide area networks are traditionally slower than local area networks. All right. So here comes a comparison between LAN and WAN, local area networks and wide area networks. That is not a big deal. That is not of importance for us, but here, actually, in distributed databases, you have a combination of both, networks as well as databases. All right. So a centralized DBMS could be physically processed by several computers distributed across a network. So there could be several separate DBMSs on several computers distributed across the network. So that is one possibility. So you have in one machine, you have Oracle running, and there can be another machine where you have Informatica, or you have some other DBMS or MySQL or Microsoft Access running on another machine. So there may be a distributed DBMS, which is made up of several database management systems distributed across a network, each with local autonomy. It is a federation. Each node is running on a different DBMS and it has got its own autonomy. Each participant in at least one global DBMS, each participate in at least one global DBMS action. Even though the individual machines are running on different DBMS, they all will be connected by a global DBMS, global database management system. The DDBMS is therefore, it can operate as a single global DBMS. So even though each individual machines are running on different DBMS, logically it seems to be a single one. All right. DDBMS is to avoid islands of information problem. So a distributed database is a logically interrelated collection of shared data and a description of this data physically distributed over a complex network. So a distributed database is actually a combination of data plus a network where containing the components or the different fragments of data. So a distributed DBMS DDBMS is a software that permits the management of the distributed database and make the distribution transparent to the users. So what do you mean by the distribution is transparent to the user? Tarun, Demira?
Hello, sir. I'm audible.
Yes, you are audible.
So, user need not really know whether he's really whether he's querying a central database or a distributed database. As long as he makes a query, the result will be given. So it will not be visible to the user.
Okay, very good. I mean, you are trying to book a ticket, and I got as Tarun has told, I got the reservation, but I need not bother whether I got the booking from the Calicut server or whether the booking was from the copy of the data which is available at Hyderabad or whether it is from the Indore station, that I need not bother. As far as I am considered, I got the reservation. And similarly, when I cancel the ticket, it will get cancelled and I will get the refund. I need not know whether I have cancelled it from the Delhi server or I cancelled it from the Amritsar server, like that. It is transparent. What exactly happening behind the mirror, that we need not know. As far as we are considered, for every action, you will get the immediate response. All right. So a distributed DBMS or DDBMS is a software that permits the management of the distributed database and make the distribution transparent to users. So that is very important. Transparency of the data. So fundamental principle is it make the distribution transparent to the user. The fact that fragments are stored and on different computers is hidden from the user. We need not bother or we need not really know that the data is stored as data fragments at the different nodes of the network. That is actually hidden from the users. So that is actually the important property of transparency in the context of distributed databases. Now we can just see a few concepts. DDBMS has got the following characteristics. It is a collection of logically related shared data, and data is split into fragments. So that is an important thing. Then the fragments can be replicated. You will have one copy of the data in say in one country, maybe in Ukraine, and you have another copy in Russia, or you have another copy of the same data in Poland. So you have the copy of the data stored in many different places. So the data is split into fragments, and fragments may also be replicated, and fragment and replicas are allocated to sites. So each of those sites or the nodes of the network will be getting the fragments. So the sites linked by a communication network. So the different communication sites are connected by communication links, maybe satellite or maybe fiber optics cable or maybe by wireless connection. The different sites will be linked as part of a communication network. And data at each site is under control of a single DBMS. So DBMSs handle local applications autonomously. Each DBMS participates in at least one global application. So every DBMS in the DDBMS will be part of at least one global application. So unless you have a global application connecting all these replicas, it is of no use. Now, the important difference between DDBMS and distributed processing, just look at these two diagrams, spend few minutes on that and tell me what is actually the difference. Satish Kumar.
Yes, sir.
Yeah, what is actually the difference between these two, DDBMS and distributed processing of a DBMS?
Sir, in DDBMS, all the site have database, and in a distributed processing of centralized DBMS, they one site have a database.
All right, so good observation. So here you have only one central store, and here actually you find there are many local databases. So site one for all queries which involves, first it will search in the local database. If present, it will answer it locally. Otherwise, it will contact the through the DDBMS, it will try to contact the copies of the data or the fragments stored in other places of the network. Good. Now, distributed processing of a centralized database has got the following characteristics. So it is much more tightly coupled than a DBMS. Okay, if you consider centralized DBMS, then you have tight coupling. All right. Database design is the same as a standard DBMS, no attempt to reflect organizational structure. When it is coming to distributed processing of a centralized database, there is no attempt to reflect the organizational structure in the database, DBMS. So it is much simpler than DDBMS. The centralized databases are much simpler than distributed database management systems. So it has more security than DDBMS. Centralized databases, you can implement better security mechanisms than distributed database management systems. So there is no local autonomy in the case of centralized databases. You have local autonomy in the case of DDBMS. All right, so important difference between DDBMS and parallel databases. So here comes another term, parallel database. So you have shared memory and shared disk and shared nothing architecture. The first case, you can see that you have a shared memory, and in the diagram B, you find that you have shared disk. And finally, you see a situation where you have nothing to share. Okay. See, there are three different ways of, there are three different forms of parallel databases. First is a occasion, or it is a model where you share the memory. Then you see that the secondary memory or the disk is shared. And third one is actually the shared nothing. On the left side, you find the DDBMS, where you find local database associated with every site. So here comes a comparison, looking at the advantages and comparing it with disadvantages. So databases, centralized databases are actually, distributed databases are actually reflecting the organizational structure. Can anybody say more on that, or how it is describing or reflecting the organizational structure? Sahil Jain.
Yes, sir.
How a DDBMS is reflecting the organization structure?
Sir, it represent how database is organized in that system, by like how complex it is, how much cost is included.
Can anyone else open to all? Anyone can answer how this DDBMS is reflecting the organizational structure?
Sir, for an example of a bank, every local bank can store its own data in its own DBMS, which is connected to the network, and there can be some main headquarters where the replicas of this local databases can be stored. So that way everything is connected, but still the organization structure is maintained in terms of databases.
All right. Anyone else add something more to what Divyanshu has told? Yeah, I mean, what exactly an organization is looking like that you can, I mean, you will tailor or you will design the DBMS accordingly. I don't know whether this can be a good example. For example, you know that there are 31 NITs in the country. All right. So you have an NIT at Calicut, and you have an NIT at Trichy, and you have another NIT at Warangal, and you have another NIT at Surathkal. So if you are having a distributed DDBMS for NITs alone, maybe the servers are kept at Calicut, Warangal, or Surathkal, Trichy, Nagpur, like that. So otherwise, these cities or these places are not going to be very important in these states. They are not capital cities. For example, Warangal is I mean, not a big city at all in Telangana, or Surathkal is not a very big city in Karnataka. But still, when you reflect, I mean, when you are trying to develop something for all 31 NITs, you go for servers at these places. Similarly, if you have a major branch in Bangalore, you have a big server there. And if you have a small and you have a local hard disk there, but if you have smaller locations, you may not be having local storage. So like that, the DDBMS normally we can say it reflects the DDBMS, it can reflect the organizational structure. And it provides improved shareability and local autonomy. No need to explain. Improves availability, improves reliability, improves the performance, and of course, economics wise also, cost wise also, this is better. And it provides modular growth also. All right. So what is this modular growth means? Rocky. What is this modular growth? Rocky. Rocky has already left. Okay. Agninjit.
Yes, sir.
Yeah.
It's
So
a
what do you, how is
it's
the
a
modular growth is supported, or it is coming as an advantage or outcome of
yes, sir. It concerns the individual sites without bothering the other sites. It's a unit by unit growth.
so in the network you can add more units. For example,
Yes,
in which is your city, Agninjit?
I'm sir Howrah, sir.
Howrah, okay.
Yes, sir.
So suppose in Howrah a new branch of a bank is coming, or they are opening. Tell me few other cities in West Bengal other
Sir,
than
Kolkata,
Kolkata.
sir. Kolkata.
Other than Kolkata.
Digha.
Sure.
Sir, Konnagar.
Okay.
Sir, Katwa.
Okay.
English Bazar.
Durgapur is it?
Yes, sir. Durgapur is also fine.
Okay. Okay. So let us assume that two branches are being opened for a bank, one in Howrah and in Durgapur. Then you can add those things, or you can have local hard disk there, and you can add the network, or you can go for a modular growth of the thing. All right. And suppose the branch at Durgapur has closed, you can just remove that from the network. So it can be done like a tree, addition of new nodes, etc. is very easy. And the disadvantages of or the demerits of this scheme is it is going to be highly complex. The cost is going to be more because you have to replicate hard disk or you need to storage. You need storage everywhere, and security will be a problem because all individual nodes may not be having the same level of security. So sometimes it will be a breach of security occurring, and it will be difficult to locate where exactly the security breach has occurred. And integrity control will be difficult, and it will be difficult to implement standards, and there will be lack of experience. There will be database designs will also be more complex in the context of distributed database management systems. All right. So these are some of the disadvantages or demerits of DDBMS. All right. So the most important thing is actually the security. Complexity, it will become more complex, and security will be a problem, and database designs may become more complex. So these are some of the disadvantages of going for a DBMS. Any questions on this? Yeah. Now going more into DDBMS, you can have two types of distributed database management systems. One is homogeneous and other is called heterogeneous DBMS. DDBMS. So you have homogeneous where everywhere the same type of DBMS is used, and in heterogeneous you have different types of DBMS used in different nodes of the network. For example, you have Oracle at one place, and you have in another node MySQL, and you have PostgreSQL in a third node, or you may have Microsoft Access in a fourth node, like that. All right, so that is heterogeneous. So homogeneous means all sites use the same DBMS product, and it is much easier to design and manage, of course. And this approach provides incremental growth, and it allows increased performance. Whereas in the case of heterogeneous, you have the freedom to choose different DBMS for different nodes. So sites may run different DBMS products, and they may have different underlying data models also. So sites can implement their own database. So integration is considered at a later point of time. So the translations required to allow for different hardware. So you may use different hardware at different locations, and you have different DBMS products and different hardware and DBMS products. In the case of translations required to allow for different hardware and DBMS products, and there is a typical solution that is the use of gateways. So you can use gateway software to deal with the heterogeneity that may come in a distributed environment. So, okay, now there comes another issue, which is actually the interoperability. The open group formed formed specification working group. So SWG, it is actually the open group which was formed for coming up with the specifications for DDBMS to provide specifications that create database infrastructure environment where there is a common SQL API, there is a common database protocol, and a common network protocol. So this open group has come up with specifications involving common SQL API, application program interface, and common database protocol, and a common network protocol. So just go through the different points quickly. So this is especially useful in the case of heterogeneous databases. There comes interoperability issue. To deal with that, you have specifications where you have common APIs, SQL APIs, and you have common database protocols, and you have a common network protocol. All right. Okay, so we will see more about the different functions of DBMS and its architecture in detail in the coming class.